Hey everyone, welcome to the R Masterclass lecture 7, and this would be the lecture second of our data visualization series. And in this we are going to look at some different graphs. Basically we are going to look at how you could plot categorical data, and we are going to look at some cool graphs, and here you could see some of these images. And with this I hope you are excited, and let's get started. So now let us look at how you could do data visualization. But before we jump onto the data visualization, we need data, and this data could be further divided into two parts, that is categorical data and quantitative data. So first let us look at what is categorical data. Basically the data which could be divided into groups. So these groups could be race, sex and education level. So for example, the education level could be some student, their highest education level could be bachelor's degree, some could be PhD, some could have masters, some could have a degree in BSc, and similarly, let's take another example. We could divide this sex into two parts, that is male and female. So you got the idea that categorical data are the data which could be divided into groups. Now let us look at what is quantitative data. Basically the data which represents data represented by numerical. And for to take any example of this, you could take example weight, height, yes, we could take also age. So these are the data represented by numerical values. For example, this could be age, height and weight. So let us look once more what is quantitative data. Quantitative data are the data represented by numerically, including anything that can be counted, measured or given a numerical value. And for example of this could be age, height and weight, because these are numerically represented. Now, now we have got an idea of what kind of data we are going to deal with. Basically it could be categorical data or quantitative data, and based on this our graph could be divided into three parts, that is univariate graphs, bivariate graphs and multivariate graphs, and the name suggests their definition itself. So in univariate graphs we plot against single categorical data or quantitative data. It could be a single categorical data or single quantitative data. Similarly, for bivariate, we plot against two categorical data or quantitative data. And multivariate, we plot against three, or we could have more. So three categorical data or quantitative data. Now let's deep dive into the univariate graphs. So for data visualization we need data, and I am currently on the website of our documentation. And if you remember, in lecture 1 we have installed a lot of packages, and one of the packages was mosaic data. And in what does this mosaic data packages does is it basically installs lot of datas, and basically it contains lot of data regarding health, marriage, health protection, helpful, weather, snow GR, utilities, riders and lot of data. But basically we are going to deal with the marriage data records, and it is containing categorical data. You could see that it have categorical data such as race, age could be a quantitative data, date of birth could be quantitative data. We could see the college, this could be categorical data, and you could divide this data variables parameters into categorical data or quantitative data. So first we are going to look at the bar chart. So for this we need to open our studio. I have already opened it. So for the bar chart we need to create a new file. We are going to create a new file, and basically we know the shortcut, that is Control Shift N, and it creates a file for us. Let us save it. We are going to name it bar chart plot. I have already created one, so I'm going to replace it. Yes, and the first thing we need to do is need to import ggplot2 library. ggplot2, we imported it successfully. Let me see. And here we need to get our data. So we need to call data marriage, and then you could see that we need to call a package. So we are going to call package, and we are going to call our mosaic data, and then we are going to, let's say, import it the data marriage data set into some kind of variable. So marriage data, let us for our sake purposes to look at what kind of data we are going to deal with. So we have saved it. Let us run this, and in the environment you could see the marriage data, and here we could see booking page ID, app date, ceremony date, delay, official title, person, DOB, trace, pref count, and pref cons, HS, college. I don't know what pref cons does, so let us look at what does pref cons indicate. The way the last marriage ended, so we don't need to do anything of that. Basically what we are going to do is we are going to plot a univariate graph, single plot, against the data race. So we know the ggplot2, and in this we are going to import our data from the marriage, and we need to call the aesthetic. In this we going to pass our x-axis as race, so let us say race, and then we need to plot a geom, and here we have lot of option. We are going to plot a bar chart, and then we are going to save it and run it. Here we have our plot, and let me zoom it. In this plot you could see that the number of marriages in this data set was this data set basically is from Alabama, USA. So white marriages is greater, then we have black, then we have kind of Hispanic, and then American Indian. Now once we have plotted it, let us look at how you could make this more visualized appealing. To make the bar plot more appealing, we could add labels, and we remember to add labels we need to call the function labs. And to make this plot more appealing, we could fill the color and add a color bar color also. Now let us make our plot more appealing and add our labels into it. So basically we could fill the color, let's say font blue, and font flower blue actually the correct name, and let us call our color basically the border color to be black, and let us add into double quote. This is good. Now let us add labs into it. So let us name our x axis to be race, y could be count, y is count, title could be, let's say, participants by race. And now we have our graph, which is much more beautiful. Now the general method to plot a bar plot is to have a percentage, and to change the count to percentage we need to use after stat method. Basically what it does, it provides the count specifically in particular group, for example in black, the number of count in black, and we could divide it by some, we will get our percentage. So we will call y is equal to after stat, and then we'll provide count, and then in this we could call some data, and we'll save it. We could change the y parameter in labs to %, and let us save and run. Okay, so we have gotten a typo. We need to provide a count here. So basically the issue was that we have a typo in some, we provided the data which is in a variable does not exist, and our compiler throws an error. So here we get the data, we could see the percentage, and here we could see that around 20% is about black, we have 1% about American Indian, Hispanic, and about 90% about participant white. Now let us convert these into the percentage. Now you might be getting the values in not in percent. To get the values in percent, we need to call scales, and basically we need to scale y and y continuous, universe, and in from this we pass labels, and we call scales, and from in this we call percentage method, Let us save, run it, Ctrl Shift Enter. We get an error that we could not find scales y. So why? Because it's a typo, basically scales y, and its s was extra, so we get the scale by continuous y percentage, and here we could see around 1% is about American Indian, Hispanic, then we have black about 22 percentage, and then we have almost 90% about 80 to 90% about white. Now let us look at some miscellaneous example. So first we could look at, now let us look at overlapping issue. So there might be cases in which your coordinate, that categorical label, will be overlapping with each other. So now let's see that case, overlapping labels, and in this we'll basically plot or ggplot2 marriage data, and then let's say aesthetic, and then in this we want to plot against official title. Let us save it. We plot geom bar, and let us add plus, and let us save it. And here you could see now the plot have overlapping labels. So how you could solve this? Basically, one method you could do is call a method that is known as coordinate flip, and you could do this by coordinate flip, and what it does, it basically flips the coordinates. So basically your x-axis become y and y become x. So you will understand much more easily when I run this code. You could see now the official title is here. You could get all the details, and if you see this you might think you need to add also the labels. So now let us add labels method, because the y-axis is not showing the correct thing. So we call label, we say x is or official title, we say y is participant count, basically we could say count also in short, and then we give the title participants by official title. And now let us add 2, fix it, let us save it, run it, we get our labels correctly. So instead of using coordinate flip, we could have one more method. That is, what we could do is basically get the text from the x-axis and just rotate it by 45 degrees. And sounds overwhelming, but it is not that tough. So we call plus, basically add theme, and this from this axis dot x dot text we call element text, and we just rotate angle by 45 degree and then adjust it by 1. And here it says theme element is not defined, so there is a, it should be element text dot x, and then we run it, it runs perfectly, we get our count, and in x-axis we see that overlapping is not happening in the x labels. Now we have learned how to plot a bar chart. It's time to look at how you could do this in PyPlot, and it's very simple. So first we will need to import our GG Py library where we could do our PyPlot, and from this what we need to do is we need to call our data, and we pass marriage, we need to import from the package exact data, and then we just need to call PyPlot ggpy, and here we could see we need to pass a group data, group key, and count type, which could be and a fill color. Yep. So we could do it very simply. So we pass data to be or marriage, and then we need to pass count type, which could be either count or full. So we say full, we say fill color, let's say null, and yeah, then we are good to go. So press enter. We are missing group key, so basically we need group key is which variable you need to map with. So here this is a univariate graph, so we could map it with say race is not found, and here we have a typo that we need to add it in double quote. So once we're done with it, you could see 74% are white, we have 22% black, 1% American Indian and Hispanic. Now now it's time to look at one more type of graph that is known as tree map. And you might be wondering what a tree map is. So basically here it is a tree map and the graphs are shown in rectangular form. And here you could see these plots are in nested rectangular format, and basically the more the area, the more the count is. And here you could see this is the, you have seen this graph a lot in stock market, and basically you could see the usage of these types of graphs. And basically the more the area is, the more the market cap it is. So at the time of this graph, the Apple was having much more market cap than Microsoft, than Google, than Meta, than Amazon and Tesla. And here the more the area is, the more the market cap is. And basically you could see it's more than Nvidia. But if you see latest one, might be it have been changed because Nvidia might have much more market cap than any other company now because of artificial intelligence. Now let us see how you could do this plot in tree map. So basically first we need to import a library or ggplot2. Then we need to import a library tree amplify for our tree plot. Then once this is done, we need to create a count, marriage count, that basically gives us the count for our marriage. So marriage count, basically it will give us the count for our official marriage titles. So we create table, we get our marriage, and then from this we import official title, and then names, marriage count, we get as count, make the column as concatenate or official title as count. As count. Let's enter, we get our marriage count, and here you could see the official title and count of it. Now it's very easy to plot it. Basically what we do is ggplot2 marriage count, and from this we need to call aesthetics, and in this we call fill for our official title. Then we say area is based on the count. Then our label should be official title. We save it, and then we just need to create a tree map. So and then we run it, and here we get our tree map. And basically you could see that marriage official is lies here, ministry lies here, pastor lies here, and bishop lies here. But we need suppose text on our graph, so we'll add this, say geom tree map text, and then we say grow is equal to true, basically to fit our text into the plot, and reflow is equal to true. basically for fitting our data. We save our code, re-enter, and here you could see that this is for pastor, marriage official, minister, circuit judge, and etc. Now it's time to look at the waveform plot or chart. Basically, in this, the plot is represented by a grid or a square box, and each square box contains the particular area of the percentage that it contains. So now it's time to look at how you could use waffle plot in R. To plot this, we need to first import our library, that is waffle, and then we call ggplot, and then in this we call pass or marriage count, we say aesthetics, in this we say fill or official title or value would be count, and then we need to call geom waffle, and basically if we need to also pass a parameter that if it contains any null values, remove it. We save it, we run it, and here is our waffle plot. It looks prettier than, I think, bar plot and or tree map. Basically, we could see that the marriage official have high count, then we have ministers, and similarly in the same count we have pastor, then the least we have is for circuit judge, elder, and Catholic priest and bishop. So you could start to deduce many facts from this graph. Now it's time to look onto the quantitative graph. Now it's time to look at the quantitative data. So previously we have discussed what is quantitative data and what is categorical data. In categorical data we have seen different types of plots. Now it's time to look at what is quantitative data and what are the charts you could use for data visualization. For basically quantitative data is the data representation in numerical form. So the data which contains numerical value is called quantitative data. So this could be the age, weight, and so on. And basically this could be represented in histogram, kernel density, or dot plot. And if you wonder what, and we are going to look each plot in detail. So for the first part we are going to look at what is histogram. So basically histogram is a type of a bar chart that represents the distribution of a data set, and we could group this data into ranges, which is known as bins, and we could see how many categorical falls into that range, and the height of the each bar plot represents the frequency. So here is a histogram, and here we could see the range, it lies here. By default in R the bins value is 30, and here the vertical height, if I show you this vertical height is representing the frequency. So you could imagine it's lying about 70k around here. So this is representing its frequency. There are two terminology in histogram that we need to get crystal clear. In histogram, there are two important concepts that we need to know about is bins, and second one is bandwidth. Now let us look in detail what is bins and bandwidth. So suppose you have a score of 20 students of their examination. So this is the scores of students out of 100. So what would be the bins for this? So bins are basically the ranges into which the data is grouped. So we could group this into 50 to 59. Basically, minimum range would be that 50, because after 50 we don't have a below score than 50, and we could take a size of 10, and the size is known as bandwidth. So basically, bins are the ranges into which data is grouped, and the size of the bins is known as bandwidth. And here we could look, if we bin this and like group this data into of size of 10, we could get bin first bin 50 to 59, then second or 60 to 69, and so on. We get till bin 590 to 99. And if we want to look into detail, what is bandwidth is basically the size of bin, and here the size of bin is 10, so or bin is bandwidth is 10. And if we want to look into detail, how much student score in scoring the score in bin is basically one student have score base in 50 to 59 range, and 60 to 69 we have two students, basically 60 to 65. Similarly, for bin 3 we have 7 students, basically the maximum we have students scoring range in the bin 3, and so on. We could do for the other category of bins. Now it's time to open our RStudio. Now first what will we do is create a new file, and to create a new file, Control Shift N, and let us save it first in our directory. So I will save it into my R master class and name it as histogram. So first we need to import our library. We import the library and we will name it ggplot2 basically for our histogram, and then we will import our data marriage, and basically we will import it from our mosaic data. And in this we have already looked onto the what data is. What we will do is we will start plotting it. So we will say ggplot, and then we will pass marriage, and then we will, for aesthetics, we will plot against, suppose, quantitative data. So we will plot against the age. So our aesthetics, and then we'll say x will be our range, and sorry, age, and then what we will do is basically say we need a geom slash histogram, and we get the histogram. We will add some title also into it, labs, and then we will say x is equal to or show or age, and then we could give it a title that is participants by age. We will save it, we'll run it, and here we get our histogram. We could see that here there is no data value available for our participants from the range 58 to 70. We don't have any values. What we could do is we could also prettify it. We could say fill we could say it fill, let's say we want it to be a color blue, and one of the favorite color is cornflower blue. It's have very aesthetic color, and then in the color of the border we could say it black. Save it, run it, we get our histogram in a much prettified way. Also, now we have learned about bins and width. We could define our bins and width in geohistogram plot. So basically what we could do is we could say basically the default value of bins and width bins is 30. We could change it and say bins is equal to, let's say we say 5, and let's run it. We get much more depth value, and basically it's if we reduce our bin value we get oversimplified data, and 30 is in okayish range. If we increase it, we get exemplified data, like over amplified data. So if we increase value to 60, you would see over amplified data. So we should have a range in between. So 30 is a good way. We could also set bin width. Let's say bin width. Let's enter it, and we get the size of our bins set it to be 60. Let's say we increase it, let's say 160, we get similar value that we have. So now we have seen how you could plot histogram. It's time to look at how you could plot kernel density plot. Before we look onto the kernel density plot, we should know what is kernel density plot is. So let's jump into it. Now it's time to look at what is kernel density plot is. Basically, kernel density plot is smooth out histograms that creates a continuous curve of the underlying data distribution. So once we get the histogram, if we smooth out the histogram, we get a continuous curve that is known as kernel density plot. We need to know about one more thing into this is basically the smoothing parameter. And what is smoothing parameter is basically it's the bandwidth in kernel density. So basically it represents the size of the bins in the kernel density. So if we want to plot this in R, let's see how we could do this plotting in R. Now it's time to look at how you could plot kernel density plot in R. So first thing, we will import our favorite library, that is ggplot. Then we will import our data, marriage, we need package, import mosaic data. Then we will say ggplot, we need to import from the data package, or aesthetics would be X, in which we will plot the age, and we need to plot a geom kernel density plot. So density plot, we will import it. We'll say labs, and our title would be participants by age. We save it, we run it, we get our kernel density plot. Now we have got our kernel density plot. We could also fill this color to make it much more beautiful. So cornflower blue, we get our participants by age. Now in this we could also add one more parameter that is known as smoothing parameter. We have looked at that is represented by BW. Basically it's bandwidth, and if we could smooth out this, change this, and we get much more width, like much more size. If we reduce this size, we get exemplified data, and if we increase this data, we get oversimplified data. So if we say 10, we get oversimplified data. Now it's time to look at onto the dot plot. Now it's time to look at what is dot plot. So in dot plot, each observation is represented by a dot, and the width of the dot represents the bin width, and dots are basically stacked one upon each other, and it is similar to histogram basically, and it is represented by basically each observation is represented by a dot, and it is well for a graph which have small number of data set. And if we look onto dot plot, here's our dot plot is basically each data points are represented by a dot, that is a point. Now let's see how you could do this in R. So we have opened our ggplot2. Now what we are going to call is geom. Let us remove everything and do again by scratch. So let's say library, we import our favorite library ggplot2. We will say we need to import our data. So first thing what we're going to do is import our data. We know how to import our data. Marriage, we say package is equal to mosaic data, and we'll say ggplot. In this we need to get our marriage data. We in this aesthetics would be our x-axis in which we show the age, and let's add geom, and we need to represent the dot plot. So for this we need called dot plot, and we will add title to it, labs, and then in the y we could say it's the count, and in x we could say age title is equal to participants by age. We need to add this whole thing in double quotes, else our compiler will throw a error. Now let us save it, run it, we get our dot plot. We could beautify this by adding a fill. Fill is equal to, our favorite color is cornflower blue, and we could also add a background color, border color, that is black, which we already have by default. Now let us revise for a moment. We have looked onto the histogram. What is histogram is? We have looked, kernel density is basically a histogram, that is modified version of it. We have looked, dot plot is basically also a histogram where each observation is represented by dot. We have looked how you could do this quantitative plot. We have looked how you could do categorical plot, and in this we have looked onto how you could plot for univariate graphs. And in the next lecture we are going to look for the bivariant graphs. With this, I will see you on to the next lecture. Thank you everyone.